In this example, we're going to look at the graphs of r equals a sine theta and r equals a cos theta. And we're going to use as our example r equals 4 sine theta. We have a table of values going from 0 to 360 in degrees. You may work in radians, and later when we do calculus, you will be working in radians. For sine 0, we know sine 0 is 0, so that one is going to be 0. Sine of 30 is a half, 4 times a half is 2. Now the other values you may want to get with the calculator. This one to 2 decimal places is 2.83. This one is 3.46. The sine of 90 is 1. 4 times that is 4. And then this one will be 3.46, 2.83, 2, and the sine of 180 is 0, so this is going to be 0. Now the values are going to be negative, and we'll look at how to deal with those shortly. So we have negative 2, negative 2.83, negative 3.46, negative 4, negative 3.46, negative 2.83, negative 2, and back to 0. So now we're going to plot those. So at 0 degrees, we have r equals 0. At 30 degrees, r is equal to 2. So that's this point just here. At 45 degrees, it's 2.83, which is somewhere around here. 60 degrees is 3.46, which will be very close to 3.5 there. And then at 90 degrees we have 4. 120 degrees is 3.46. 135 degrees is 2.83. 150 degrees is 2, and then 180 is 0. Now for the negative values of r, in some courses you may find that negative values are not counted, so you don't plot them at all. But in this course, we're going to treat negative values in the following way. We have 210, negative 2. Now, 210 is along this line just here. But because it's negative 2, we say it's 2 in the opposite direction. So it actually lands back on that other point. And the same is going to be true of 225, negative 2.83, it will land on this one, and 240, negative 3.46, it will stick out in the opposite direction. Remember that 240 would be this ray just here, and so we're going in the opposite direction. And then 270, negative 4, 270 is down here, stick out in the opposite direction. So what happens is we land back on all of the same points. The picture we've built up is of a circle. So it's going to look something like that. In fact, I have a better picture of it just here. So r equals 4 sine theta looks like this. Remember that the path is traced twice, once for the positive values of r and once for the negative values of r. Once you know that r equals 4 sine theta looks like this, it should be relatively clear that r equals 4 cos theta will look like this. And we can explain that by looking at these graphs. The red one here is y equals sine x, and the blue one is y equals cos x. And we can see that they're the same shape. But if we consider the cos x and this maximum here and the maximum just here on the sin x graph, the sin x has been moved this way. In other words, cos x has a 90-degree translation compared to sin x. And we can see here that if we rotate this around 90 degrees, then we get this one.